Hey y'all, happy Monday. So glad you're here joining us for our recorded synchronous class where we are all learning the same things at the same time today. I am so glad you're here, and I want to throw you into our math today. We're going to continue talking about adding fractions with different units, different denominators. But today, we're going to stop drawing our rectangular fraction models and get into some other mathematical ways of solving these problems. But before I tell you all the secrets of math, I want you to dive into this problem right here and start with 1/2 plus 1/5. So pause this video, take a shot at this problem, solve it any way you want, and we'll come back together and talk it through. Awesome. So if you're like me, you probably started with our fraction model, our rectangular fraction model, where we had two rectangles, one to represent 1/2 and one to represent 1/5. Now I know in my 1/2 I needed to shade in 1/2. Now my 1/5 I needed to shade in 1/5. So then in order to get, let me slide that up there a little bit. In order to get my like units, my same denominators, I have to transpose my half line to the other side and then the other way around as well. So I'm going to take my half line, I'm going to move it over here and cut that 1/5 and the other fifths into half. And then I'm going to transpose my lines from our 1/5 model to our 1/2 model. You see us moving them over there, which means we would need to separate this, partition this, is the fancy math word for separate, into 5 parts. So now that we've done that, we can count up our total shaded parts, and our total shaded parts are 5. And then we have 10 total parts altogether. Over here, we had 2 shaded parts out of 10 total parts altogether. And now that we have our unit of tens, we can just add these two fractions together. 5/10 plus 2/10 equals 7/10. Well, and that'll work pretty well for a lot of things. I love our rectangular fraction model. It helps me visualize what is going on and remember that I'm not changing the amount that is shaded in. But when we start getting small units where we have bigger numbers as our units, as our denominators, then we would have to draw a lot of boxes. But I wonder, I bet you've started to notice this too. When we had 2 and 5, we multiply them together and got our like unit down here at 10. So 2 times 5, let me try, 2 times 5 is 10. So what we said was 2 times 5 is 10. But let's write this fraction out all together. 1/2, and we want equivalent fractions. So we know if we do something to the bottom, the denominator, we also need to do it to the top because that keeps everything balanced. So we're going to do 2 times 5 to get 10, and then 1 times 5 is 5. So our equivalent fraction is 1/2 is equal to 5/10. Now we're going to try this the same thing with our other fraction over here, 1/5. We knew our like unit was tenths, so we had a 10 on the bottom there. And we need to get to 10, we had to multiply 5 times 2. 5 times 2 is 10. I'll flatten that up so we can see that. So sorry about that, y'all. And we know if we did it to the bottom, we would also have to do it to the top. We are going to illustrate why that is in just one moment. But for right now, we remember from 4th grade and before, if we do something to one part of the fraction, we also have to do it to the bottom to make sure it is equivalent. So 1 times 2 is 2 tenths. Well, guess what? We can now rewrite our equation, 5/10 plus 2/10. And this is the same as our original equation, because we've taken the equivalent fractions we had at the top up here, and our equivalent fractions to 1/2 plus 1/5 is right down here, 5/10 plus 7/10, and 5/10 plus 7/10, 5/10 plus 2/10 equals 7/10. 5/10 plus 2/10. equals 7/10. So now the only thing we're going to do last is put our answer up at the top. 1/2 plus 1/5 equals 7/10. Okay. Now you're probably wondering, how can we find our like unit, our bottom number? Well, we want to use our multiples of the numbers that we're starting with. And our multiples are essentially our times tables. Just dropped my orange pen, so I guess we're going to use pink, y'all. So we're going to take a look at 1/2 plus 2/3. Now we want to list our factors of 2 off to the side here. So 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 8, 10, 12, so on and so forth. And then we're going to list our factors of 3. So we do 3, 6, 9, 12, 15, 18. And then we want to look at numbers that appear in both our pink list and our blue list. Well, I see that 6 is on both of these. And I see that 12 is on both of these. So 2 common factors, or 2 numbers that we could make like units, are 6 and 12. And I'm going to let you on a little secret. The smaller number we choose, the easier it's going to be. So I want to choose 6 here. So then we're going to ask ourselves, 2 times what equals 6? Well, I know that 2 times 3 equals 6. And if we do something to our bottom number, we're also going to have to do it to our top number. So 1 times 3 is 3. Then we have to find, so 1/2 is equivalent or equal to 3/6. Now we want to ask ourselves, hey, let's take our 2/3 times something equals 6. We know our denominator, that bottom number, has to be 6. So 3 times something equals 6. I know that you know that we know that 3 times 2 equals 6. And if we do it to the bottom, we also have to do it to the top. So we have 2 times 2, and 2 times 2 is 4. Now we can rewrite this problem with our equivalent fractions. So we're rewriting 1/2 plus 2/3 with our equivalent fractions. So we have 3/6 plus 4/6. I know now that our denominator is the same, our unit is going to be 6, and our numerator is going to be 7. So we have 7/6. Now I bet you can convert that into a mixed number. You learned that back in the first semester. That is equal to 1 and 1/6. If you need a refresher on how to convert improper fraction to mixed numbers, stop by our help session or shoot me a message and I can help you out. Now there's one other thing we want to take a look at. One thing that is super cool with these numbers. We have this fraction here. So we essentially had 1/2 times 3/3. And 2/3 times 2/2. Now what we remember is we can rewrite this, and I'm putting this on a post-it note, so you don't need to write this down. But we remember that we can rewrite our fraction as a division problem. So this right here, well, it says 3/3, is also 3 divided by 3. And we know that 3 divided by 3 is 1. And down here we have the same thing. We have 2/2, which we can rewrite as a division problem, 2 divided by 2. And 2 divided by 2 absolutely equals 1. So when we are solving these problems, what we're really doing is multiplying our fraction that we're starting with by 1. It's a strange looking 1, but it is 1. And we remember that when you multiply anything by 1, you end up with what you start with. 2 times 1 is 2. 17 times 1 is 17. 3,432 times 1 is 3,432. Heck, Mr. Spencer times 1 is Mr. Spencer. Wow, it even works with things that aren't numbers. Awesome. So we take our fraction, we multiply it by 1, It's a strange looking one. And then we get our equivalent fraction. All right. Yeah, it's time for a tough one. I hope you're ready. We're going to take on this problem. 5/9 plus 5/6. What do you notice about this problem that is different than the rest? I notice that both of these are bigger than 1/2. I notice that 5/9 is bigger than 1/2, and 5/6 is bigger than 1/2. So when you add something bigger than 1/2 to something else bigger than 1/2, you end up with an answer bigger than 1. So our answer here is going to end up being bigger than 1. But our process is going to be the exact same. I'm going to start with our multiples of 9. We have 9, 18, 27, 36, 45, 54. And then we are also going to do our multiples of 6. 6, 12, 18, 24, 30, 36, and that's all I have space for. Oh, I'm out of space there. Yeah, I'm just going to shrink this down a smidge. We're just all over the place. So sorry about that. There we go. Now I'm going to look at our numbers that are both in our multiples of 9s and our multiples of 6. Our pink multiples and our purple multiples. Well, I see that 18 is in both of these. And so is 36. So we could use either of these as our common unit, our like unit, our denominator. Now if you want something a little tougher, use 36. If you want to take the easy route, use 18. So we now need to rewrite our equation here. We need to find the equivalent fractions. We know we're going to multiply 5/9 times something up top and something at bottom. Sorry, something on top and something on the bottom. And then our denominator in the end is going to be 18. So we're going to ask ourselves, 9 times what is 18? Well, 9 times 2 is 18. And we remember we have to multiply by 1 to not change anything. So if we have a 2 on the bottom, we also need a 2 in our numerator. So then we would multiply 5 times 2. And 5 times 2 is 10. Now let's rewrite our 5/6 as an equivalent fraction. And we're going to ask ourselves, in order to find our common unit, our like denominator, we're going to multiply 6 times something to equal 18. Well, I know 6 times 3 is 18. And we also have to do it to the top, so 5 times 3 is 15. Well, now that we have both of these written out, we can simply add these together. 10/18 and 15/18. And since our bottom unit, our like number, our denominator, is the same, we can simply add our numerators. So 10 plus 15 is 25. Wow, I'm just all over the place there. So sorry, y'all. I'll slide this over. So we have created our equivalent fractions with a like unit, the same denominator. And then we added our two equivalent fractions together. Now this is a 10. I'm super sorry about that. We have 10 plus 15 equals 25. And I know that you know how to reduce that into a mixed number from our improper fraction. And then you would end up with 1 and 7/18. Now I want to challenge you with our last problem of the day. I'm going to flip the page. And I'm going to put it right here. 2/3 plus 1/4. But wait, there's more. Plus 1/2. So I'm giving you a problem with 3 fractions to add together. Oh my goodness. That means you're going to need your multiples of 3. your multiples of 4, and your multiples of 2. And then you're going to have to find a like unit. Give this problem a shot, and then you'll be good to go. Once you've solved that problem, your exit ticket for today, there will be a spot for you to turn this in on our asynchronous day tomorrow on Tuesday. Your exit ticket problem today is this: 1/6 plus 3/4. So give this super tough problem a shot here, and then your exit ticket is right here at the bottom. Awesome, y'all, that is it for today. Have an amazing rest of your day, and I will see y'all soon. Bye, y'all.